Okay, talking about predicate functions. So these are functions that return logical values. Basically, they are answering yes or no questions, but in computer science we say true and false instead of yes and no. So let's just ask a couple of questions. Well, we can ask whether 0 is 0, and that's true. 0 happens to be a 0, but of course we don't ask it like that. We might do some actual calculation there, and it's like, yeah, that's the 1 is not 0. We can also ask whether we have a positive number, and this is supposed to be true. How about 0 itself? Okay, that's not a positive number. And we can also ask whether we have a negative number, and in that case, yes. So you might see that these predicate functions, as they are called, they end their names end up with a question mark. That's just a convention, but it's a very, very useful one. It's not always the case. For example, if there is a sort of mathematical operator available, then you don't need to do that. So this one is actually a bit more interesting, because we can ask things like these. Okay, so this happens to be true. What this says, again, the same trick. You might want to put the operator between the numbers, as we did in prefix arithmetic. So it's basically not just one statement, but a bunch of statements. So you might get, okay, let's start a new code block. So for example, if I double that, so now it's false, because 1 is not strictly smaller than itself. But we can be more permissive, and in that case we have true. Similarly, we can talk about equality here. Well, we can ask whether 42 is really just incrementing 41 or decrementing 43. Again, you can have several arguments. You check the equality. Okay, at this point we might just slightly touch upon a topic, the types, that is actually quite big, and that could be a decisive factor between different programming languages. So, for example, we can ask, is 42 a number? And true, it happens to be a number. But if I ask whether ink is a number, and that's false, because ink is a function. We have a predicate function for that. We can ask, is ink a function? And that's true. We can also ask, is plus operator is a function? And yes, it is a function. So, yeah, depending on the programming language, you might have a very strict type system, or you can have a more permissive, less strict type system. So what is a type? And it's that's a big question, but you might want to think about it as like you have a piece of information, piece of data, and what's the type? The type will give you the set of operations that you can apply to that piece of data. So if we have a number, then we can do arithmetic. If we have a function, we can call it, and we can compose with other functions. So it's like, yeah, the type determines what you can do with that. And it's okay. For example, here we are in the browser, so we are on top of JavaScript. JavaScript is not too strict about types. So if you ask the question, it's like, is number 3 is the same as 3.0, which is like, you know, common sense says, that's the same thing. So that's true. However, you will see if you are in Clojure on top of Java, then there is a difference between these two, because you have a different representation. So this one is an integer and the other one is a floating point number. And it's like, okay, we can check that this and 3 is an integer, certainly. That's the case. And if we ask, is 3.0 an integer, it's a, you know, it's a different data literal. It's it has a decimal point in it, and the Clojure script says that it is the same. And if I ask, is this a floating point number? 3. Okay, well, it's like, yeah, that's true. And if I ask, is this a floating point number? Well, that's true again. But let's say if I ask, is this an integer? It's a whole number, 3.1. Okay, well, then we have some difference at least. Okay, so it's like, you will see that when you do Clojure in the browser, that's basically it's Clojure script, most likely, then it is very permissive. You don't have too strong distinctions between different types of objects. So, well, let's have an excursion to Clojure on top of Java. Here we are in a Clojure repo on top of Java, hosted in Java. And now, well, I can do things like, let's just double check that is 3.0 an integer, and that's false, because it's like, well, once you have the decimal point, and you have a different internal representation. Therefore, Java says it's a lot more strict. It says that that is actually different. And also, you have some options here. For example, rational numbers. And it's like, yeah, if you divide 1 by 2, and that's indeed a rational number. And it's a difference. So it's a 1 divided by 2 as a symbolic fraction. That's a different thing compared to 0.5. So let's double check that. Okay, that's false, because it's a different type. You have a different internal representation. So what should you do is, like, if you say that, I want to be, I'm in Clojure and I want to be more generous, more permissive about this comparison. Just like, for my purposes, these are the same numbers. And it's like, well, you can use this other equality operator, and that will consider them as numbers, whether the numerical value is the same. And that's okay. I can ask whether 3 is a floating point number, and that's false, because it's represented as a integer number. While yeah, we did this one before, and that's true. Okay, so the types are not set in stone. It's a decision of the language how much distinction you do between the different pieces of information, And yeah, keep that in mind, depending on which REPL you are, Clojure script versus Clojure, and to make sure that you don't get bitten by these typing issues.